Alright, we are going to be reconnecting a balanced load from Y to delta and comparing their values. So in this case, here's a balanced Y connected load, and over here is going to be a balance, the same load that we have connected here. We're going to reconnect it to delta. In our scenario here, we're going to have a 208 volt three-phase supply, and each resistor is 12 ohms. So in both scenarios, it's 208 with 12 ohm resistance in each phase. So let's go ahead and determine the values in Y, what we would get. So I would first do is to draw out the three resistors connected in Y. I'm going to put the supply voltage here. Now when it says supply, that is meaning that is the V line. It equals 208. So we go ahead and put that on there. 208 volts. We've got 12 ohms of opposition in each phase. So we can do next is we can determine the phase voltage. So V phase would be equal to V line divided by root 3. So that's 208 volts divided by the root of 3. That should come to approximately 120 volts. So I can put that there. So that means each resistance would see a volt drop across it of 120 volts. I can now calculate my phase current. Phase current would be equal to the voltage across the phase divided by the opposition in each phase. In this case it's just resistance. So that's 120 volts divided by 12 ohms. That comes to 10 amps. So our I of our phase is 10 amps. We know that in Y, I line is equal to I phase. So whatever current is flowing through this resistor is coming through the line. There's only one path. So I line is the same as I phase. So that is 10 amps. If I go and compare it to our delta, still going to be the same 208 volt supply, and the oppositions are 312 ohm resistors still, so same opposition. Let's compare it to see what our values look like when we're connected in delta. Well, the first rule for delta is that V line is the same as V phase. There's only one voltage. That means that if I have a V line here of 208, then I'm going to see the full 208 volts across our 12 ohm resistor, because V phase and V line are the same. So we'll go ahead and put that on. Now the I of the phase, same formula. I take my phase voltage and I divide it by the opposition in each phase. So that's 208 volts divided by 12 ohms. That comes to about 17.33 amps. And the line current, because this is a balanced circuit, we can use our formula. I line equals I phase times root 3. So balanced only. So that would come to 17.33 amps times root 3. Should get approximately 30 amps. Okay, so I'm going to put these all on a chart, and so we can see them side by side and look at what the difference is. For the phase voltage, the Y load had 120 volts in the phase, but the delta had a 208 volt phase voltage. So we see the difference in phase voltage. It's root 3 higher in delta than it is in Y. The line voltages are the same. That is our supply. So that is no change. The phase current in Y was 10 amps, but because our phase voltage was root 3 higher, our phase current is root 3 higher as well. It came to 17.33, so it's root 3 difference times by root 3. The line current in Y was the same as the phase current at 10 amps. But if we look over here on the delta, it's 30 amps. So the difference when we reconnect from Y to delta, the same 3 loads to the same supply, we would get a line current that's 3 times higher in delta than we would in Y. So knowing the differences, we can work it the other direction as well. If I had a load in delta and I wanted to reconnect it to Y, I know that the line current in Y will be 1/3 of what it is in delta. I hope this helps you. We'll see you on the next video.